So today we are going to be graphing cosecant and secant graphs. Now, in order to graph these, it is easiest to first graph the reciprocals. So first you would graph sine, and you would also first graph cosine, depending on which reciprocal function you have. It's easiest to graph the originals first, and then just make a few little adjustments to then graph the cosecant and secant graphs. So this is why I said that today is just kind of an extension of last class when we were graphing sine and cosine, because guess what? We're going to be graphing sine and cosine again. I'm sure you're all so happy to hear that. All right, first we're graphing cosecant, and cosecant is the reciprocal of sine. So another way to write this is 1 over sine. Now our variable in this equation is t. Whoops, what happened? So it is 1 over sine of t is another way you can write this. So first, we're going to graph the parent sine function. So last class, what we did first, when we were graphing the parent function, we wrote the 5 main angles on a circle: 0, 90, 180, 270, and 360. The first and the last angles there are actually at the same point. Then we wrote down our y values. The center dotted line is actually centered at 0 for our parent function. The top line is at 1, and the bottom line is at -1. And then we remembered that sine makes the pattern middle, top, middle, bottom, middle. So I'm going to graph that: middle, top, middle, bottom, middle. And I'm going to, in between my points, instead of drawing a solid line for this sine graph, I'm going to put a dotted line just so that I know that this isn't the actual graph I'm trying to complete here. This is just a reference line so that I can graph my cosecant. So again, what I just graphed in orange, so the orange dotted line is my sine of t line. So now let's think about this just a little bit. We'll do the easy ones first. We're trying to graph the reciprocal of this graph, meaning whatever y values we have at a point, we take them and we find the reciprocal of that y value. So let's do the easy, like I said, the easy one first. At this 90-degree angle, I have a y value of 1. What is the reciprocal of 1? That's the negative reciprocal, Sydney. -1 would be the negative reciprocal. Yes. 1, any whole number is always over an invisible 1. So 1 over 1, the reciprocal of that is still 1 over 1. So the reciprocal of 1 is just 1. Meaning that at 90 degrees, my cosecant graph is at that exact same point. Let's do the second easy one, -1. What is the reciprocal of -1? Yeah, it's still just -1. So that means at the 270-degree angle, cosecant shares a point with sine as well. Now, what is the reciprocal of 0? It's not 0. It's not 1. Okay. So we got that sine value of 0 by having a 0 in the numerator. and something else in the denominator, because anything that has 0 in the numerator is equal to 0. Right? Yes, exactly. So when we have 0 in the numerator and we're finding the reciprocal of that value, 0 goes in the denominator. What can you never divide by? 0. So anything divided by 0 becomes undefined. When or what on a graph is undefined? There are two things. Two things represented on a graph makes our graph undefined. How do we show an undefined moment on a graph? There are two ways. You're so on the right track. You're so on the right track, Lauren. You're close, but it's okay. So the first one is a hole, right? A hole is a discontinuity on the graph that makes the graph undefined at that value. What is the other one? It starts with an A. A-S. Yes, it's an asymptote. So here, whenever we have 0 as the sign value, the reciprocal of it is undefined, creating an asymptote. Meaning anywhere that my sine function goes through the middle, it creates an asymptote for our cosecant graph. So at 0 degrees is an asymptote, at 180 degrees is an asymptote, and at 360 is an asymptote. Anytime sine goes through the middle, it creates an asymptote for the cosecant graph. And then the way that you graph the rest of this is we know that cosecant shares the top point and the bottom point. And then the cosecant graph does whatever it can to go towards, it approaches the asymptote while also going away from the middle. So here at this top point, it goes towards the asymptote, away from the middle. Towards the asymptote, away from the middle. Same with the bottom point. It goes towards the asymptote, away from the middle, towards the asymptote, away from the middle. And I'm done. That is my cosecant graph. This also repeats endlessly, right? So there's another top point here that goes like this. There's another bottom point here that goes like this with an asymptote between them like this. Oh, I drew that really awfully. It goes on forever. With the topmost U shape there, the upwards facing parabola or U shape, combined with the downward facing parabola, creates one wave. Both of those together creates the single wave. So the period length here is still how much? How long is one wave? Yes, it's still 360. Thank you, Samantha. Or in radians, that's 2 pi. Math Excel, unfortunately, does want your answer, for the period anyway, in terms of 2 pi. I'm sorry, in terms of radians. So we would say it's 2 pi here. Are there any questions about this graph, how we graphed here? All right, so let's go ahead and do the exact same thing, but with secant now, which we know secant is the reciprocal of cosine. So we can also write this as y equals 1 over the cosine of t. It is the reciprocal of cosine. And we're going to start the exact same way by writing our 5 angles: 0, 90, 180, 270, and 360. Our center line, y value is 0, the top line is 1, bottom line is -1. Now cosine, we're going to, again, I'm going to graph it as dotted and in orange for you guys. Cosine has the pattern of, what just happened? Okay, has the pattern of top, middle, bottom, middle, top. So I put a point at the top, middle, bottom, middle, top. Oh, I was about to draw a solid line. But we want a dotted line because we want to know that this is not actually part of our secant graph. This is just helping us to draw our secant graph. Now you complete it the exact same way. You draw asymptotes when the cosine graph hits the middle line. So we have an asymptote at 90 this time. We have an asymptote at 270. And then secant shares the top. Oh my gosh, it's going all over. Secant shares the top points. And it shares the bottom point. And then it does whatever it can to go towards the asymptote away from the middle. And that's our secant graph. So this is a single wave. It starts like in the halfway through a parabola and ends halfway through a parabola. Just know that if we were drawing more than one wave, because it does continue onwards forever in both directions, it would continue these parabolas. But that's not part of a single wave. This is a single wave. So our period length here is still 360 or 2 pi. All right, moving on. We are now going to be looking at, now all of this information is good information, but I've basically already walked you through this. I've already verbally said most of this. So I'm not going to read it out for you right now. What we are going to do is we're going to look at transformation functions. So we're going to look at these cosecant and secant graphs instead being transformed from the parent functions. So first thing we always do, and I wish that we had written the table here because I really love these tables, but for some reason we didn't write it here, which is fine. First thing we do is identify A, B, H, and K. That's step 1. Step 1, always identify A, B, H, and K. I don't really know why they did a capital A here, but it's fine. It's whatever. What is our A value? Good. Yes, it's 2. I think, so what I normally do when we're in class is I think I've mentioned them before, these silly little popsicle sticks. I really think that I need to like start doing popsicle sticks. Then our A value is 2, which also means our amplitude. The A value is also our amplitude. Our amplitude is also 2. What is our B value? Yeah, there is no number right in front of the X, so there's always an invisible 1. Now we said, I think Sydney was the one who asked, but we said earlier the way that Math Excel asks for B is by asking for omega, which is like this curly W looking thing. It's actually, I know you guys, well, I don't know, but this, I drew it awfully, is actually the uppercase symbol for omega in Greek, where this is the lowercase. Makes no sense to me, but that's what it is. All right. What is our H value? Yes. Now, remember that H is always backwards. So if it says plus 30, we're actually moving where? Yes, left 30. So H is actually negative 30. And what's K? Yes, exactly. Always. That's always it. Um, so then yes, K is the up and down. So K here is that negative 1, meaning we're moving this whole graph down 1. And we're moving the whole graph left 30. So now, two more things that we need to find before we start graphing. We need to find the period, which last class we learned we can find period by doing 360 divided by b. Now our b value here is 1. So 360 divided by 1 is just 360. So our period length is still the same as the parent function. It's still just 360. On Math Excel, they want you to write the period in that table in terms of radians. So the other form, so either you can take this 360 and convert it into radians by multiplying by pi over 180, or you can just immediately find it in terms of radians by instead knowing the formula in radians, which is 2 pi over b. And this should make sense because 360 is the same as 2 pi. So here, our period is 2 pi as well. But we are going to use degrees to graph because it is easier to find all of the tick marks in terms of degrees. Now, how do we find the rest of the tick marks? Right, yes, you take your period, which is 360, and you divide it by 4. I should probably write that formula. Period divided by 4. So we have 360 divided by 4, which is how much? 90, yes. Now, in the chart, after we found this is also called the tick mark width, this increment is also called the tick mark width. After we found the tick mark width, we, before we started graphing, found the rest of the tick marks. We do this by taking the starting point, which is always our H value, and adding 90 degrees each time. So negative 30 plus 90 is 60. Plus 90 is 150. Plus 90 is 240. Plus 90 is 330. And we only need 5 because there are 5 major tick marks in any sine or cosine graph. So then the next step, it doesn't matter which you do first, your x values or your y values. I always like to do the x values because we should have already found them. We always start at the h value. Always start at h. Negative 30, 60, 150, 240, and 330. Now, now that we've completed writing the x values, now we have to figure out the y values. Where is that centered dotted line always located? That's where the parent function is located. What variable tells us where it is centered on the y? H told us where it starts on the x-axis. Yes, K tells us where it is centered on the y-axis. So here, because our K is -1, it means that the center dotted line is centered at -1. How do we find where the top line is located? Right, yes. We take the A value and we add it to that K value of -1. So -1 plus 2 is 1. We do the exact opposite to get the bottom. We subtract 2. So our bottom line is at -3. These are from our amplitudes. I know there's a lot of lines going on here. All right, so now is the easy part. We first graph the sine graph because cosecant is the reciprocal of sine. So we're graphing first sine, which we know sine has the pattern of middle, top, middle, bottom, middle. Middle, top, middle, bottom, middle. And just like last time, I am going to do a dotted line to represent this sine graph because this is not actually what I'm trying to graph here. I'm trying to graph cosecant. Man, I am not being very symmetrical. Okay, now how do we take this and instead graph cosecant? Yes, you can think it out and find the reciprocals, or you know that anytime the sine graph is in its center position, its middle position, it creates a what? Starts with an A. AS. Yes! Anytime our function has what are called its zeros, the middle points, our new graph has an asymptote. So I'm going to draw an asymptote through -30. I'm going to draw an asymptote through 150 and an asymptote through 330 because this is where the sine graph has its zeros. Because the reciprocal of 0 is undefined. And then we also know that cosecant shares the top points and the bottom points. And then it does whatever it can to go away from the middle towards the asymptotes. Away from the middle. I'm so not in the middle there. Towards the asymptotes. And you're done. Are there any questions on this graph? I think I'm going to end this recording and do a separate example recording. I think that you guys appreciate it when I break it up, but I'm not sure because people don't really talk to me.